your app has to really catch their attention and say, yes, this is going to make my life 10 times better if I install this app, before they even make that choice. Whereas with the PWA, they can be surfing the web, click a link, dumped right inside your app, and they're using it right away.
Infinite Red is a US-based consultancy specializing in React and React Native. They do mobile app and web design and development. They are deeply involved in the React and React Native open source communities, publish the React Native newsletter with 10,000 subscribers, and are involved with the React Native core development. If you have a project and need design or engineering help from an experienced team to take it all the way from concept to completion, get in touch with Infinite Red. Also check out Chain React, the React Native conference, which is hosted by Infinite Red in July in Portland with 500 developers from all around the world. You can find them at infinite.red. Make sure to mention you heard about them in this ad.
Hello and welcome to React Native Radio. Today I'm your host, Nader David, and we have no one on our panel, but we do have a special guest. Today joining us is Eric Elliott.
Hi.
Thanks for coming on the show, Eric.
It's my pleasure.
So we brought Eric on the show today, or I brought Eric on the show today to kind of talk about PWAs, progressive web apps. A lot of our listeners are interested in building mobile, and mobile does not just have to fall into the category of native or React Native. We've also in the past talked about Xamarin, we've talked about Ionic, Flutter, a few other different frameworks. So today we're going to be talking about PWAs and like where they fall into the category of developing for mobile. So can you give us a quick intro before we get into the topic about yourself and kind of what you do?
Sure. So I'm Eric Elliott. I'm the author of Programming JavaScript Applications, which is published by O'Reilly. I have a new book called Composing Software, focuses more on functional programming and basically how to use better compositional patterns for your software architecture. And previously I've worked for Adobe. I helped build the Creative Cloud, which is how Adobe went from box software to a subscription model. Before that, I helped build a social video app used by BBC, Wall Street Journal, NBC, CBS, and a bunch of others. And music software that was the top music app on Facebook eventually got sold to YouTube. It's now part of YouTube artist pages. So that's a little bit about my history.
Okay, so it sounds like you've done quite a bit. What are you doing today, like is your day-to-day? Are you making income off of like these books and things, or do you actually work as a developer as well day-to-day?
So day-to-day, I lead development teams. I'm a technical advisor for companies. And I also I have several projects that I manage, and I do a lot of mentorship. So I co-founded the Dev Anywhere mentorship platform. So that's part of my day-to-day too. Okay, cool. So is there a definition for what a PWA is? I know that I've listened to podcasts, I've read articles, I've seen different opinions of what a progressive web application is, but I don't think there is like a defined, definition of what it is, or maybe there is. So can you kind of give us what you would say defines a progressive web application? So in my mind, what defines a progressive web application is an application that is built using standard web platform technology, which works really well on mobile and integrates like a native app on mobile devices. So I think that's, to me, the defining thing that makes a PWA. And I just want to clarify, a PWA is basically just following current best practices for building a web application. So,
okay, so maybe in the future, all web applications will be PWAs?
Yeah.
Maybe that's the end goal?
Yeah, I think so. At the moment, the defining feature is to include a manifest, which basically tells the operating system, gives the operating system some metadata and some icons that help it integrate it with its native workflow. And also including a service worker, which helps the application work faster and work offline when you're disconnected from the internet and so on.
Okay, so about the icons and the manifest, so that's definitely one big part of, I think, what a PWA would be defined as. So the icon is going to be something that kind of gets stored on the device. It looks like a regular application that you downloaded from the App Store, correct?
Yeah, that's correct. So that'll be the thing that gets added to your home screen. There's various sizes of icons that are used for various different kinds of things. So there's a small one that shows up in the little lists with the thumbnail icons, and there's the larger one that shows up on the desktop, and an even bigger one that shows up maybe during a loading screen when you click on the app to load it or something like that. So there's like several different icons that you have to. I think I've got one PWA that I use across a lot of devices and maintain, and I want it to look great on all devices. And I think I've got more than 20 icons in the manifest. So there's lots of different things that you need to do in order for it to look good and integrate on all the different platforms.
Okay, so like, what operating systems does this work on? So if I have an app I want to deploy for both Android and iOS, is that possible today?
Yeah. Yes.
Like as a PWA?
Yeah. In fact, so iOS was the first to do this. They had their own proprietary metadata format back in 2009. And iOS, they then focused on the apps and the App Store and native app stuff for a long time. And then they were a little bit slow to adopt the PWA standard manifests, but they're doing it now, and they've integrated Service Worker, and so now your PWA should work great on iOS and on Android. And of course, they work just like a regular web app would, but they also work on other operating systems. So Windows 10, for instance, integrates PWAs really well. And they have the Windows Store will automatically, if you have a PWA, it'll automatically suck it into the Windows Store and offer it to users who are searching for applications there. And you'll see others. I think Amazon's store does the same thing for Kindle devices, Kindle Fire devices, whatever they're called. So yeah, it integrates across all these different platforms. All the major platforms support them.
So, but you don't actually go into the App Store on iOS or Android to download these. You kind of save them to the screen, right, from the actual webpage? Is that how it works?
For now, but the trend is that the app stores will pull these in automatically and add them to their app stores.
That would be cool.
Yeah, I think that Apple currently has kind of a hard approval process to get into the store, and it sometimes takes weeks to get an app approved. I don't know if they're going to keep that manual approval for like all PWAs or what's going on with their direction. But the trend, at least so far with Windows and Amazon, is they're just automatically pulling these into the app stores. And I think we'll see that with Google. I'll almost certainly see that with Google. I can't speak for them, but I think that's what they'll do, just because that's kind of how they have handled things in the past. I think they may still have a manual approval process with Apple, but I can't really speak to that. So I can't give you any certain guarantees. However, I can tell you that that users are more likely to find and start using your application if it's a web app than if it's a native app.
So, like right off the bat, a couple of the main things I would see as a benefit of using a PWA would be one, that you can update it without having to go through the App Store. And then number two would be like what you mentioned earlier, not having to even go through the App Store at all. So, like I know that whenever we're shipping native apps or React Native, we always have to worry about updating. And if you're using React Native, there are ways around this. You can use something like Code Push or whatever, but still it's an additional part of deployment that isn't part of the just main framework. It's an addition that you have to add. So definitely I would say, PWAs being able to update. So like when the user opens the application, you can then kind of just pull down a new version of the application, right?
Yeah. So one of the things that I've been doing a lot in apps since probably all the way back to 2012, probably, is that most of my native apps are basically web views, and that allowed us to get past that approval process. Because every time we ship a new version of the mobile app, we had to wait weeks for Apple to approve it. And that just wasn't working for us because sometimes there were major bugs that needed fixing, and our customers were counting on us to get those bugs fixed quickly. And we just couldn't wait around for Apple to do their thing. So we basically just turned most of our app into a web view, and we just deploy it on our servers, and that would automatically update on the App Store without the approval process, without submitting a new code base to Apple to review and so on. So the PWAs give you that power without the need of the extra complexity of pulling in a web view. It's just how your app is built from the ground up, and you don't need that extra wrapping using some kind of framework like Cordova or something like that, right?
Yeah, totally. Cordova is definitely falls into the category of the whole web view thing. I was down that road quite a few times in the past. Works fine, but I definitely am liking React Native, and I know that people are not too crazy about Cordova these days, and they're trending towards things like the PWAs and other alternative methods.
Yeah.
So so discovery is a big one. When people are discovering applications, I kind of think it depends on the type of application you're writing. Whether or not you're even worried about discovery. Can you kind of talk about how discovery plays into the process of kind of deciding where you want or how you want to write your next application, and whether it falls into the category of why you might choose a PWA?
Sure. So what native developers need to understand is that most of your users don't have room on their phones for a new app, right? They just don't. So they're not going to the App Store and searching. Most of the discovery for apps on native is people go to the App Store and search, or they hear about something in the news, or a friend shares something and says, you got to get this app, right? And then they go into their App Store and they search for it. And as they're searching for it, they find a million other apps that do almost the same thing. And it's hard to figure out, is this the one that I'm actually looking for? And particularly on Android, a lot of these apps are really terrible apps with really invasive advertising or even malware, right? And there's quite a bit of, at least in the Android marketplace, there's quite a bit of malware, and it's kind of dangerous to go and do discovery in the App Store on Android. But the thing is that most of your users have 5 to 10 apps that they use on a regular basis, and they install, average person installs 0 new native apps per month, right? However, the average person spends about half their time on their phone browsing the web, right? And most of the other half of the time is spent in apps, in their social media apps like Facebook, Instagram, Snapchat, whatever, right? So most of your users are not spending a whole lot of time playing with their apps and searching for new apps and things like that. They're spending their time browsing the web or using their social apps. But as they're browsing the web, they can still discover web apps, right? And use them with no friction. There's no install friction with a PWA, which is one of the key advantages to PWAs over native apps. Is the first thing that your user has to decide if they want to try to install your native app is, do I have space on my phone for this? What do I have to delete and sacrifice in order to start using this app, just to check it out and see if I like it or not, right? So right away, you're asked, that's a really, really huge ask on native. And most of your users are in that situation because most of your users are using a lower grade phone or a phone that's a couple of years old, and they've been using it and filling up the space for a couple of years. And that's when they have to decide, do I want to install your app? And your app has to really catch their attention and say, yes, this is going to make my life 10 times better if I install this app, before they even make that choice. Whereas with the PWA, they can be surfing the web, click a link, dumped right inside your app, and they're using it right away, right? So the friction basically disappears. You have, on Android, there's instant apps which are trying to emulate that PWA friction, low friction entry. And maybe that'll help and that'll do a good job. But in the meantime, right now, for the best cross-platform experience of learning about a new app and starting to use it, PWAs are it.
So, just to clarify, just in case someone listening doesn't know this, because we have a lot of new people sometimes listen to the show, I'm just going to say, the difference in size is because when you're downloading an app from the App Store, you're downloading the entire, all of the code for the application, whereas when you're downloading an app or when you're installing a PWA, you're just getting the icon there, and then the actual code is being pulled down over the network, right?
That's correct. It'll cache on your device as much as it can, but you don't need to clear up space to start using a PWA. So if you don't have the space for all of the cache, it's just going to load the files every time. It won't be able to save to the cache, but it'll load the files from the network.
So you mentioned service workers earlier, and I know that one of the big things that we help customers with at AWS is when they're building applications that need to work offline, and I know that service workers kind of help that.
Yeah.
Can you talk a little bit about what service workers is, how can you use it, and then where the offline piece kind of fits into that?
Sure. So service workers are kind of a layer between your app and the network. And that layer is able to intercept network requests and build custom responses for those network requests, which means that you can use them as a caching layer for your application assets. And that's a really good thing because that means that if you have assets, including things like JSON API responses, things like that, that can be cached, you can cache them on the local device, and then your network requests can be simulated offline, right? So it won't actually hit the network. Instead, it'll hit the cache and load it from the local device. And in that way, you can make your app completely functional offline, even if it relies on a JSON API or something like that.
So where is this cache? What cache are you referencing? And why can't this be done without a service worker, I guess?
Why can't this be done without a service worker?
Maybe, for instance, you have something stored in local storage or something like that. Or maybe you have, I guess that would be the one thing I could think of that would be similar.
So the difference is that, there's a couple of differences. The size limits are different, right? So you'll have, with local storage, you'll run into various different size limits across architectures and things like that. There is no built-in size limit per se for service workers, as far as I understand it. So if it doesn't fit, it just won't cache, and it'll go hit the network for it, right? Whereas with if you're trying to use local storage and you run out of space, you just can't store that thing, and then trying to fetch from your local storage isn't going to work. Whereas service workers, it's just like making a network request. So in your code, you treat it like you're hitting the network every time. And that gives you this transparent API. So you don't have to worry about caching in the context of your app. You don't have to implement custom logic. That is all encapsulated behind the service worker. So you get all the benefits of this application asset caching without any of the headaches of worrying about the caching logic in the logic of your application itself, right? You still have to worry about it inside the service work. You have to figure out, am I getting this from cache, or am I serving it from the network, or how am I dealing with this situation when the network requests come in? But you deal with that once, you get it working, and then it forever hides behind the service worker, and you treat it like a regular network request. So that's kind of a big deal. Okay, yeah, that makes sense. But I mean, what is the name of the cache that we're using? Is it something just that's part of service worker? I'm asking because I've never actually written this from scratch myself, and I'm kind of curious. Is it because I know with async storage or local storage, you call local storage get? Is there a method or something like that people could check into? I don't. So you set it up once, you get it working, and then you forget about it while you're building your app. So I don't have all the service worker API details memorized because I set it up once at the beginning of my app and then I forget that it's there. That's the thing. That's what makes it so cool, is you set it up once, you get it working for a particular asset, and then you forget that it's even there. So okay, nice. I just call it service worker cache, right? I know that there's a cache. It lives inside my service worker, and then I forget that it exists.
Nice. So basically, if you have it set up properly, the user goes offline. They request some data. If the user is offline, they pull down the most recent version of the cache data, I guess.
Yep.
What about making like things like operations on an API, like mutations or creates and updates, I guess? Would that be something you can handle and kind of update the UI optimistically?
Sure, absolutely. So what I do is I make all of my data transactional so that I can create kind of a diff between what's on my local device and what should be stored on the server, right? By sending the transactions to the server when we go back online. So you can save up all those data transactions with the API and update your local UI optimistically, and then on the server, it'll connect and receive all of those updates the next time you connect online. If you do it transactionally, that makes it a lot easier to do things like rollback state if something didn't work or things like that. So you basically treat your data like it's immutable, like a bank account, right? Where you have a bank account, you submit you have a balance, you submit a transaction, you don't directly mutate the balance and change that. Instead, that transaction gets applied over a series of transactions, just like a reducer. So if you're familiar with functional programming and reducers, you get some new piece of data and you somehow fold that into the current state, right? And it's like that. So you can undo and replay these events that are coming in, and you can kind of figure out what the state is supposed to be on the server, even though there's a ton of atomic transactions that happen to the client while it was offline.
Okay, yeah, that sounds pretty interesting. So where can people learn more about how to work offline with service workers? Is it part of, I guess, Mozilla documentation these days, or where's the best place to learn? Or do you have any blog posts about it or anything?
I have a blog post that kind of just does a brief introduction of the concept. The hardest part for me was just getting it set up. Service workers have to have HTTPS, which should be okay because hopefully everything you're doing on the web is HTTPS right now. So they have to be HTTPS for security reasons, and that was the hardest part for me, is just getting that to function in my local environment, and also getting it to function the same in my local environment as it does online deployed. Right, that was the hardest part for me. But hopefully it should be a lot easier now because there's better tooling for it. I started playing with service workers when they were still kind of an iffy specification level thing, getting like experimental support in Chrome and stuff like that. Now there's much better support. You should have a smoother entry into it. There's a lot more resources online teaching you how to do it. And there's a lot fewer bugs and cross-browser inconsistencies now. You're probably still going to run into some cross-browser inconsistencies for some of the newer parts of the API. Even for the manifest file, it's still kind of in flux a little bit as new platforms add support and quirks are worked out. Things change. I've noticed things have changed a lot in the last couple of years. So just staying on top of those changes and making sure that your app works well across all devices is great. If you're following the specification though, and you can't get it to work on some platform, you may find that part of the specification just hasn't been implemented yet on that platform. And you might find that's the case for some things on iOS, for instance. But I have a PWA that I mostly put together a couple of years ago, and it just magically started working better on Android Chrome one day on my Android device. It's installed on my Android device like a native app would be installed. And it just magically started working better one day. It's because Chrome shipped default support for one of the features that I was using on some of the other platforms. And the experience just magically got better. So if you're following the spec, hopefully, and you're able to test it on one platform, maybe the experience will improve magically and automatically on another platform as well. So you'll find that it's still kind of cutting edge. There's still some stuff to be implemented and some quirks to be worked out, but it's pretty good. As far as learning it, MDN is a good resource, but Google, the Google camp has a lot of information about PWAs. You can go and read their case. They have got a bunch of case studies about companies have switched to PWAs and seen the results, and you can see some of their metrics and some of the benefits that they've enjoyed from that. So you'll see things like 60% improved stickiness or 60% reduced abandonment or, things like that where they'll double some of their numbers that are critical KPIs for their application just by switching from a native device or a native app to a PWA from an old style web app to a modern PWA.
Nice. Very cool. So I guess one other thing about PWAs is performance and the idea of kind of having a snappy feel. Does this kind of mean that most PWAs need to be single page apps, or can you still build PWAs using traditional like server side rendering, and kind of what goes into the thought process of building when you're kind of taking into consideration the feel of what a modern PWA should kind of feel like?
So all of my apps are server-side universal apps. So they render on both the server and the client. But once you get a page on the client, it can load other pages without going and fetching the whole thing and pulling everything back. So it'll send probably just a JSON blob with some of the different data updates when you switch pages on the client. So it kind of acts like an SPA, but these are definitely not like traditional SPAs in the sense that you can go to any URL and it'll be addressable and renderable from the server side, and it'll show up and render correctly in your app. And by renderable on the server side, I mean anything that doesn't necessarily require a login unless your backend is also handling the user data state, right? So you've got some kind of token or something that enables your server to know about the user state. And in that case, you can render everything on the server side and all the pages, including the user data and everything on the server side, and ship it to the front end already ready to go. So that means that bookmarking works, deep links work, those kinds of things. Whereas with a traditional SPA, those things were usually broken because people didn't really know how to build out those applications correctly back then.
Yeah, so I guess that goes a lot to do with how you have your routing and stuff like that set up. And so do you choose like a certain framework when you build these types of things? I know there's Next.js that does this kind of server-side rendering, but also client updating like an SPA. Once you hit a certain route, you can treat it as an SPA.
Yeah.
So what do you use like as your typical, like if you were going to build an app today, what would be your stack, your tech stack?
I use Next.js on the server and on the server and the client, right? So basically I'm writing one code base that works both on the server and the client, and it reduces the amount of code that I have to write by about 70%. It used to be that we'd have to build a separate middle tier application that would serve the kind of the shells, right? And you don't have to do that when you're using something like Next.js. And there's a lot of additional benefits to using something like Next.js because it automatically does page splitting and bundle splitting and all kinds of really great optimization tricks. So, for example, I have one app that I was working on that it was the first app that I built with Next. And I'd been doing other things and just building out features and not concentrating on performance and trying to optimize page load very much. And then one day I noticed that my page loads were 60% faster. And it's because I'd upgraded Next.js and they'd added some really tremendous optimizations to the page loads. And so it just magically makes your app faster as Next gets better at optimizing how the pages load and translate. So I use Next. They're really, really good about staying on top of things, and developing it, and they just do a really tremendous job maintaining and making it the best it can be. So it is by far my favorite universal JavaScript framework by a long shot. And of course, it relies on Express on Node and on the back end, and React for rendering both on the back end and on the front end. And then you can easily integrate things like Redux for state management, or Apollo, or whatever you're using. So you can integrate GraphQL and things like that pretty easily.
Yeah, Next is sweet. The guys behind that are like really, really awesome.
They're on top of their game. They're doing a great job.
For the first time.
What's that?
Yeah, it was like like using Next for the first time was like one of those aha moments. Like, wow, this is so simple and it works so good.
Yeah.
Like, be real.
Yeah. So before we did that, I was writing tutorials on how to do your own universal JavaScript applications and set up the server side, and using React Router and all kinds of stuff, and doing all this custom craziness on the server side to get everything working properly. And I just use Next, right? Because what I would find is that APIs would break. That it's a moving target. You'd have your app would break when you upgraded things, and you'd have to go and figure out the new APIs and figure out how to make everything work. Whereas with Next, I just build my Next app and I let Next worry about staying on top of all those things, and it radically reduced the maintenance chore of keeping up with all of that stuff and making those things work smoothly, and optimization too. So the page load optimization is a huge task. It can be a full-time job, like just keeping up on what you can do to optimize those bundles and make your page splitting work better and better. And there's still room to improve. And the Next guys are just on top of it and shipping improvements in performance and things like that on a regular basis. So just use Next.
Yeah, I agree. So another thing, I guess, that falls into this category that a lot of people are going to be thinking about when they build their apps is performance and latency as far as like network requests go. I know this is more of a general application question, not really specific to PWAs, but when you're working with your APIs, if you could build a new API from scratch today, like would you use GraphQL or would you use REST? I know a lot of people are using GraphQL and taking advantage of the benefits of kind of lowering the payloads that are going across the network to improve the performance. But do you have any opinions around that?
So that depends. Are you pushing out an MVP and just trying to get something working, or are you building an app that needs to scale over the long term? If you're doing the former, a simple REST API that you can whip together in 5 minutes in Node and Express is probably your best bet. If you're building something that you're going to have to maintain over the course of years, that has millions of users, and you're dealing with millions of objects, and querying is a big deal, right? And being able to get various views of that data is a big deal, then use GraphQL, because GraphQL is currently my favorite solution for that. It's the easiest way it's basically, there is no good query solution that works across the stack from the front end to the back end, except for GraphQL. And by good, I mean, it's got a lot of support. There's a lot of documentation on how to use the thing. There's a good developer community you can fall back on if you have questions. There are other querying options on the front end, but GraphQL is the best that I know of by a landslide. So, depends.
Yeah,
how complex is your app, right?
If you're going to be building an MVP, there's no reason to invest all this time to kind of like build out the sophisticated backend if you don't even know if you're going to keep it or not.
Yeah, exactly. If you don't need to express queries from the front end, don't use GraphQL because it's overkill. But if you do need to express queries from the front end, then GraphQL is by far the best option in my opinion.
So do you worry about things like animations, for example, or transitions between different routes when you're building your applications?
I don't.
Or should people think about that when they're building PWAs, I guess?
I don't worry about it while I'm building my applications because you can tack it on, right? And by tack it on, I mean like if you use Next and you use their links and their routing functionality, you can express those animations later, right? You don't have to do it up front. It's hiding behind an abstraction. So even if you swap out, for example, their link tag for something else that maybe wraps their link tag or wraps their router so that you've got their routing capabilities under the hood, but then you're wrapping some animation around it, that's fine, right? So I don't worry about it at all. And if I need to make a custom animation for some routing translation or something like that, so from some page change or something like that, I can just import a different link tag and just encapsulate the animation inside that link tag. So I don't worry about it at all while I'm prototyping my app, and I do tack it on later. I'm not super good at animations myself, so I'll fall back on the expertise of some better UX animation designers, and I'll let them deal with those kinds of things later. But the fact that you can encapsulate it inside this link tag or inside custom link tabs, so you can design different transition animations for different parts of the app. So some of them, they make sense to have stuff slide in and cover up what was on the page, right? And some of them make sense if it just automatically switches, just like if you click a button and it just, boom, it just magically appears. Sometimes that makes sense. Sometimes the user needs to see what the relationship is in the data hierarchy. And then an animation can help the user figure out what's going on in the UI, right? So you got to think about interaction design and animation design are an important part of user experience. But as you're building the app, you don't have to worry about that stuff. Just hide that behind a link, right? Or some kind of...
That makes sense. First, you want to make sure like everything, you want to build like the basic functionality out, and then you kind of worry about polishing it up later.
Yeah. But you should have those things in mind. Like, is this going to need an animation? And if it is, then you should highlight that and make sure that there's a ticket to follow up on it and make sure that it gets implemented. But those things can be added as improvements to the UI while you're shipping your MVP or working on your MVP for demos, for customer demos, or just to show your progress. Don't worry too much about it. So the perfect is the enemy of the good, right? Don't worry about like every little detail when you're coding, and don't interrupt the flow of the logic of figuring out what are the customer requirements that I have to satisfy here to go off on some deep dive on animations and transitions, right? Because I can spend 6 hours fiddling with the transition, and then a proper UX animation designer can do a better one in 5 minutes. Right. So I don't really worry about it while I'm coding. I just make a note, hey, a transition would be nice here, but then I'll let somebody more qualified do that work for me because I'm just not an expert in that area.
So like, what do you think about type JavaScript? Do you work with just plain vanilla JavaScript, or do you like using Flow or TypeScript?
So I use vanilla JavaScript because it's more expressive. So typed JavaScript is limiting on purpose, right? It's intentionally shutting down features of the language that it doesn't want you to use. And the reason for that is to try to give you type safety. Now, the problem with type safety is that it doesn't exist. So, and when I say it doesn't exist, I mean like
or in JavaScript.
In general, I looked at a bunch of empirical studies on this, and as far as I can tell, there is no strong correlation between static types and there's a relationship, but there isn't a strong effect between static types and reduced bugs. So that effect it's there, but it's very, very weak. So on average across GitHub projects, you can measure maybe 3% change in defects density using TypeScript. Now, that sounds like a big deal. Hey, we can reduce our bugs by 3%. But when you do that, you're also shutting down a lot of features of JavaScript, and you're making it so that you require more code to accomplish the same things. And you're also And the TypeScript fanatics are going to be like, no, you're wrong. But no, seriously, there's a lot of stuff that you just can't type in TypeScript that is idiomatic JavaScript. But another problem is that if you're using TDD and you're using code reviews, right? Code reviews, for each hour spent in code reviews saves something like 33 hours in maintenance. So, and primarily like reducing bugs and improving architecture and stuff like that, right? And TDD reduces production bug density between 40 and 80%, right? And there's empirical studies I can back up these numbers with, and I've studied this in depth and written about it in lots of blog posts. And there's an entire book called The Economics of Software Quality that goes into great detail about the effects of bugs and bug density on your applications. We need a lot more empirical studies and good academic coverage of these topics to really be sure about these things. But the effects are so obviously different that it makes it really, really clear. If you want to improve code quality, static types are way down on the list compared to other things that you can do, like implementing code reviews and TDD. So
that's interesting. 3%, and I know that pretty much every TypeScript project I've ever worked on, I've probably spent another 20 to 30% of my time just getting the types.
Just working the types. Yeah. Just working on the types. And another thing that people don't consider is that adding TypeScript adds another bug vector to your application because types can be buggy. Right? And people don't even think about that. They think this is going to protect us from bugs, but it actually adds another bug vector to your application that you have to figure out, why isn't this working? You figure it out mostly at compile time, because if you have TypeScript set up properly, it's going to fail your compile when the types don't check out right. However, you're also going to run into situations where some things should be valid types that are not working, and other situations where TypeScript should be complaining, but it's not, because it's easily confused by compositional patterns, including higher order functions. In particular, it has real trouble figuring out higher order functions, and you just can't type a lot of higher order functions properly using TypeScript. It's just not possible because the language isn't expressive enough to handle it. So that's primarily why I don't use TypeScript for most of my applications. I do include it in a couple of my libraries, which are simple enough that they are easy to type. And that's just because I want to make it convenient for TypeScript users to use those libraries. However, and I was using TypeScript full time for some projects. So everybody who's thinking, oh, he just doesn't know anything about TypeScript, I used it full time. I've studied type systems for a long time. I cut my teeth on C++ and Java. I know Haskell, which has a much better type system than TypeScript. Much better, like order of magnitude better than TypeScript. So it's not that I don't understand static types. It's that TypeScript has some fundamental weaknesses that they need to fix. I'm not saying that they can't be fixed, though. I'm really hopeful that they will patch up these issues, maybe add higher kinded types, maybe get a little bit more flexible about supporting interfaces that are more complicated than a class, right? Or not just more complicated, but look different than a class, right? TypeScript is really good at typing things that look like classes because the designers of TypeScript are really familiar with things that look like classes. Problem in JavaScript is there's a lot of idiomatic JavaScript that doesn't look anything like a class and is more functional in nature or more compositional in nature or more dynamic in nature than a class ever was or can be. And in those areas, that's where TypeScript tends to fall on its face and not be very good for your productivity. And by that, I mean that you will try to do something that TypeScript just doesn't support good typings for, and you'll bang your head on it for like half an hour, an hour. That's an hour that you would never have even considered spending if you were not using TypeScript. And if you're primarily using TypeScript because you think it's going to save you from bugs, stop right now, throw it away, because it's not going to save you from bugs. If you're using TypeScript for the developer tooling, keep at it if it's not getting in your way too much, because it does provide really great developer tooling. I really like how the interface of working in your IDE improves when you add TypeScript. However, a lot of the benefits that you can get from that, you can get just by setting default values in your constructor functions and things like that to provide type hints for type inference like turn.js and stuff like that. So you can get a lot of the same benefits using something that doesn't restrict you as much as TypeScript and has way lower overhead.
Yeah, I mean, interesting. I know that the main problem with TypeScript is that it's not part of the specification of JavaScript. So you're basically having another layer of abstraction that could be problematic as it's not part of the main language. There's always going to be issues there, I think. Whereas if you're using something that is a typed language, it just works how it should out of the box. But What about like these other compiled to JS languages like Reason, Dart, Elm? There's other ones out there. Something interesting that came out in the last week is Dart, or actually Flutter, released a web framework and also released a desktop framework, kind of putting it in a similar category of React Native. So with Flutter, you can now compile to web, desktop, iOS, and Android. And of course, you can just compile straight up to JavaScript. There's kind of like a framework now to build web applications. And I like Dart because Dart is typed, it is a typed language. So you end up with really nice support in your IDE. You kind of don't have to worry about using a TypeScript compiler, and you don't have to worry about any third-party library you're using, whether or not it has types and whether or not they're up to date. All the stuff you have to deal with TypeScript. What do you think about some of these other languages that compile to JavaScript?
So I think that if you've been using idiomatic React and React Native, then you're probably starting to acclimate yourself to functional programming kinds of things. So the languages that are like Dart, that are a little more Java-esque, might start to feel restrictive to you. Languages like Elm and PureScript and Reason ML, those might feel a little bit better. It just depends on how functional your brain is rewired, right? And how much your brain is attuned to functional programming patterns versus object-oriented programming patterns or like Java-esque programming patterns. If you like the Java-esque programming patterns, Dart might be your thing. If you like the functional approach, then check out PureScript and Reason. And Reason in particular is being used by some of the proponents of Facebook and React. So if you like the React approach, check out Reason. It might work for you. I personally don't like those very much because there is kind of a translation layer between those languages and JavaScript. So personally, I like to stay in the native JavaScript, and I'll just use those kinds of programming patterns in the JavaScript that I'm writing. I personally find JavaScript to be perfectly adequate language, and I like dynamic types because they allow you to be very expressive. I really love Haskell because it has support for higher kinded types, which is much more flexible and resilient to working with the functional programming patterns. But even in Haskell, it's kind of hard to it's hard to properly type higher order abstractions. So 2 layers of higher order abstractions. And things like transducers use those. So a transducer is a higher order reducer. So it's a higher order abstraction on top of a higher order abstraction. And it's even hard to type those in Haskell. Whereas dynamic types, you don't have to worry about how many layers of abstraction you're using or how functional your software is. It just works, right? So I like that JavaScript is a dynamic language. It gives it flexibility, right? And if you trade off a dynamic language for a statically typed language, you're making that trade-off. You're trading off some flexibility, and sometimes that flexibility is enormously useful and radically reduces the complexity of your application. So I'm not against static types, but there are good type systems and there are bad type systems, and there are more flexible type systems and there are more rigid type systems. And I tend to favor the more flexible. I tend to stay on the flexibility side rather than rather than the strictness, trying to protect yourself from your self side, right?
Yeah, and it seems like JavaScript, especially with the ES6 change, and now we're seeing additional changes come about, like in some of the newer versions, they seem to be adopting a lot of the more popular features of other languages anyway.
Yeah, JavaScript does do that. It adds some of the best features from other languages. It's certainly become even more functional over time, progressively more functional over time, and adding a lot of primitives that are, so we have support for native monads in JavaScript now. Promises kind of act like monads in some situations, and now flat map is being added to arrays, which gives it like monadic capabilities, and they were easy to create on your own before, but now it's part of the spec official, right? And it's just bringing really cool features into the language. At the same time, some of the best features from JavaScript are being adopted in other languages. And it's not just features from JavaScript in particular, but in particular, the functional programming patterns are invading the really object-oriented programming languages. And the reason for that is because they're tremendously useful, right? The promise futures abstraction is tremendously useful. So that gives you like the monads that were introduced to Haskell in the early 90s by Philip Wadler. Things like that just make life a lot easier for developers. They're coming to a lot of languages. So in the end, it really is the best features tend to seep into all the popular languages.
So we're kind of getting close to being finished on time, really. But is there anything you wanted to cover that we haven't really discussed yet before we kind of wrap it up?
Sure. So one of the things that I want to talk about is a lot of people underestimate the idea of composition and abstraction. And these are important concepts, whether you're writing for mobile devices or anything like that. If you really want to get good at React Native or progressive web apps or React in general, you need to learn how to compose things better, right? So I have a new book on this topic called Composing Software that you should check out. But basically, all software development is composition. You start out with this complex problem. You break it down into lots of smaller problems, solve those small problems, and then compose those solutions to form your applications. And that boils down to two things: function composition and object composition, right? You're composing functions and you're composing data structures. And when I ask in job interviews, what is function composition and what is object composition, and explain these things to me, most software developers don't have a good grasp of either of those concepts or how to use them well, right? And if you're building software, you're composing. And if you're composing and you don't understand function composition and object composition, you're composing badly, probably, right? So I think it's really important that we go back to the fundamentals and really understand what it is we're doing. And that's going to make your life better if you're building applications for mobile phones or applications for the web or applications for any stack, right? Those fundamentals are really where you need to start and get a really good mastery of those. Build a solid foundation before you start building your skyscraper, right?
Yeah, totally. I mean, so like to kind of go through the book, do they have to, I guess, just have a basic knowledge of like a programming language, or is it kind of written in JavaScript, or is there actual code there, or is it more about concepts?
So the examples are in JavaScript. Concepts are sometimes expressed in diagrams, in math. So I approach it from JavaScript, very, very light algebra and very, very easy to read diagrams. I don't want you to have to, it should be okay for beginners to approach, right? But I'm also not holding your hand too much. So really advanced people who've been programming for 10 plus years should be able to get a lot out of it as well. So there's a lot of stuff for just beginners, but then you can read it 10 times as an advanced practitioner and you'll probably still gain insights from it.
Okay, great. So I guess we'll go ahead and jump to the picks. I'll start with my pick. So today I am checking out this new course on egghead.io, and it's called Algorithms in JavaScript. It was just released, I think, this week, the last couple of days. It's by Tyler Clark. It's pretty cool. There's about 10 or 12 lessons. I think the entire course is around 40 minutes, so it's not that long. It's kind of a good refresher and kind of a good explanation of certain algorithms that you might be using on your everyday, day-to-day. And I actually learned a couple of new techniques there. So check it out. It's a really good course. Do you have any picks you'd like to choose, Eric?
I've got some things that I'd like to highlight, right? Just to review, we talked about Next.js. You should definitely check that out if you haven't yet. And there's really, really good documentation on the Next site that'll help you onboard to that. React's documentation has improved radically. So if you haven't looked at it for a couple of years, go back to the React website and check out their documentation. It's much, much better. Check out React hooks if you haven't yet. React hooks is a new feature coming to React that's really great. It makes it easier to program in React without using classes, and it radically simplifies those patterns that you were using React classes to come up with. So check those things out for sure.
Now, Eric, I appreciate you coming on the show. That was a really interesting discussion.
Yeah, no problem.
Well, that wraps up this episode of React Native Radio. Thanks for listening, and we'll see you next week.